Okay, so now I'm going to go over some examples of how we can use substitution to evaluate definite integrals. So let's go over this first one here where we have the integral from 0 to 1 of x times x squared plus 1 all to the third power dx. And so what we're going to do is we're going to make the u the x squared plus 1. U will be x squared plus 1. And that means du will be 2x dx. We don't have a 2x dx, but we have an x dx. And so we're going to divide this by 2. And that'll give us that 1/2 du will be equal to our x dx. Not sure why I switched back to pencil. It should stay in the pink pen. Okay, so then we can rewrite our integral as 1/2 u to the third, since we have x squared plus 1 as our u, so u to the third du. Now, here's the thing. We can't simply put that we're integrating from 0 to 1 anymore because we changed our variable of integration to u. The 0 and 1 were in terms of x. But what we can do is either we can just leave it as an indefinite integral, find the antiderivative, and then change it back to x afterwards, and then evaluate it from those two endpoints. Or we can rewrite the endpoints in terms of u. So what I mean is that here we have x is 0, and here we have x is 1. And so if we use the formula u equals x squared plus 1, when x is 0, that means u will be 0 squared plus 1, or u will just be 1. And so then we can rewrite this bottom endpoint as 1, and then we evaluate it for when x is 1. When x is 1, u will then be equal to 1 squared plus 1, which will just be 2. And then we can rewrite the top endpoint as 2. And then from here, all we have to do is finish the problem, and we don't have to worry about the variable x anymore. So I usually like doing this because I feel that it's easier and faster. So we find the antiderivative of 1/2 u to the third. That's just simply going to be 1/2 u to the fourth over 4. Let's keep our endpoints as 1 over 1 to 2. Let's clean this. Let's simplify this as 1/8 u to the fourth, and we're integrating from 1 to 2. And so now we just evaluate this, and I'm going to move this down here so it's out of the way. And we're going to have 1/8 times 2 to the fourth minus 1/8 times 1 to the fourth. So be 1/8 2 to the fourth, 2, 4, 8, 16. So 1/8 times 16 minus 1/8. So we have 2 minus 1/8, or 16/8 minus 1/8, and that'll simply just be 15/8. So just to give you a heads up, it's going to be pretty common for you to get answers that are like fractions, and a part of the problem is going to feel like you're just doing a tedious algebra problem, and you really don't want to make a mistake there because it's going to make it seem like you don't understand the calculus. I remember when I took calculus, this was something that scared me because I would worry that I would make an algebra mistake and get the problem wrong, and lose points obviously, and even though I knew the calculus. So just be careful about that. Okay, let's look at the next one. We're integrating from 0 to 4 of the square root of 2x plus 1 dx. And so what we're going to do is make the u the 2x plus 1. Du will then be 2 dx. And we almost have that. We just have a dx. So we're going to divide this by 2. And we'll get 1/2 du equals dx. And so we're going to rewrite this now as integral 1/2 this times the square root of u du. And again, these endpoints are in terms of x. So we can't just put 0 and 4 as their endpoints. But what we can do is rewrite them in terms of u, which is actually what I recommend. So let's figure out what u would be when x is 0 and when x is 4. So when x is 0, using this formula, u equals 2x plus 1, that means u will be 2 times 0 plus 1, or u will just be 1. So the bottom becomes 1. And then when x is 4, u will then be equal to 2 times 4 plus 1, which will be 9. And then so the top endpoint will be 9. And now we can just simply integrate this, which will give us, this is the same as 1/2 times u to the 1/2 power du. And I'm going to move this down over here so we have more space to work. So using the reverse power rule, this will be u to the 3/2 over 3/2, going from 1 to 9. Let's rewrite this as 1/3 u to the 3/2, integrating from 1 to 9. And let's go all the way here because we're going to make sure that we don't make a mistake here. Let's just bring that 1/3 out for now. And we'll have 9 to the 3/2 minus 1 to the 3/2, all multiplied by 1/3. So let's remember what, fractional powers are. So we're going to rewrite that 9 to the 3/2 as 9 to the 1 times 9 to the 1/2, because 3/2 is the same as 1 plus 1/2. And that 1 to the 3/2 is simply 1, as you should know. And then this is just going to be 9 times 3, because 9 to the 1/2 is the same as the square root of 9. So 9 times 3 minus 1. And so what we're going to get is 1/3 times 27 minus 1, or 1/3 times 26, which leaves us with 26/3 as our final answer. And there we go.